Okay, then here's the question, parts A and parts B. I've got the question summarized here. So let's have a go at part A then. So here, we're going to expand this using the binomial expansion. 1 plus 6x to the minus 1/3 is equal to 1 plus n x plus n n minus 1, which is minus 4/3, times x squared over 2 factorial plus dot dot dot. We only need to go up to x squareds. So what do we get? We get 1. 6 over 3 is 2, so that's minus 2x. Here, 2 can go into the 4 twice. The 6 squared is 36. 36 over 9 goes 4 times. So what do we end up with then? We've got a minus times a minus, which is a plus. 4 times 2 on the top is 8 x squareds, and there's nothing underneath. So there's the binomial expansion then for part A. Now part B. Find the binomial expansion of this up to x squareds. Well, the 27, we can take that outside a bracket, can't we, and make it look the same as this, can't we? So 27 plus 6x to the minus 1/3 is equal to 27 to the minus 1/3 when we use properties of indices. So I've taken that outside a bracket, but I've also used the property of indices. So there'll be a 1 there, plus the 6x over 27, of course, to the minus 1/3. So I hope you can see that, because power in indices times you can combine these two indices, and the 27 would be here in the bracket. And then when you run the 27 through, you'll get 27 ones, and 27 times this gives this. So it all fits. To the minus third is 1 over 27 to the third, times 1 plus 6x over 27 to the minus 1/3, which is equal to, cube root of 27 is 3, and then we get 1 plus 6x over the 27 to the minus 1/3. And now we can use our part A problem, can't we? Because we've got 1 plus 6x here, but we need to replace that with, instead of 6x, it's going to be 6x there, but over 27. So replace the x by x over 27 here. So that would be 1/3. 1 minus 2 x over 27 plus 8x over 27 squared minus dot dot dot. So that's what we've got then for this series expansion here, close bracket. So that's part B, part 1 then. Okay, given that is equal to that, approximate this to 6dp. Okay, so clearly we're going to use this series. 2 over cube root 28. The cube root of that is just 2 over the cube root of 28. So we need to make this 28, don't we? If we put x is equal to, we want to make 1, so x is a sixth here. X is a sixth. So x equals a sixth. X equals 1/6 gives. So I'm just going to try this. So put a 6 in here, we get 28 to the minus 1/3 here is equal to 1/3, 1 minus 2 times 1/6 over 27 plus 8 times This should be squared, shouldn't it? 1/6 squared over 27 squared. Okay, so that's what we think it should be. But that was 28. Let's go back to the question. 2 over cube root 28. So 2 over that will equal 2 lots of that. So I'm going to put that in straight away. And now we can just tap it in the calculator. Okay then, so we got 2/3. So 2 divided by 3 times the bracket. We've got 1 minus 2. And then it will be, the 6 can come underneath, so it's divided by bracket 6 times 27. So I can put that like that. And then plus 8 divided by bracket, and it will be 6 squared times 27 squared, wouldn't it? So 6 squared times 27 squared. Close that bracket here, and then close the bracket for the times 2/3 equals 169 over 243, 169 over 243 to 60p. Let's get the decimal. 123,456, 695,473, 695,473, and that was to 6 decimal places. Just look at that again. 473, yeah, it is. Okay, so now I'm going to do this as a sum to see if that's correct. So 2 divided by 28 to the power cube root. So 2 divided by 28 to the power 1/3, wasn't it? 1 divided by 3. 658,633. So it's quite out, isn't it? Okay, I'm just going to try this again then, because I didn't get the right output. So let's try this again, see if I made any mistake. So it's 2 divided by 3 times bracket 1 minus 2 divided by 6 times 27, wasn't it? So 2 divided by bracket, and bring the 6 down, 6 times 27, just write that in, close bracket, plus 8 divided by bracket, and then it's 6 squared times 27 squared, isn't it? See if I can enter that correctly. 8 divided by bracket, there we go, 6 squared divided times 27 squared, close bracket, and then close the bracket for the 2/3. 658, so I must have typed something wrong. 658,639, isn't it? Which is what we had before. 658,639. 0.658639. So it's nice that we can check our answers for questions like this with the calculator to make sure we don't make a mistake. And I illustrated that well here.